Two parallel lines intersect at one point. Xiefeng. Euclidean geometry asserts that two parallel straight lines can never intersect. Einstein, considering the perspective of the universe, hypothesized that two parallel lines might intersect, but he did not provide proof, and to this day, scientists have not been able to prove it. Euclid proved the parallel line postulate from the perspective of a two-dimensional plane. Even in three-dimensional space, Euclid's parallel line postulate holds true and cannot be overturned. Assuming that the multiverse theory in quantum mechanics string theory is accurate, even in such a scenario, two parallel straight lines cannot intersect at one point. Einstein reasoned that massive objects could cause space to deform and curve. When light encounters an object with sufficient mass, gravity prevents it from traveling in a straight line, so two parallel lines might intersect at a certain point due to this curvature. Therefore, he believed that Euclidean geometry might not be a universal principle. Some scientists consider time as a dimension, and this has scientific reasoning, because any object undoubtedly exists within time and evolves with the passage of time, unable to escape time's palm. However, scientists view time with conventional thinking. Although, according to the principles of general relativity, time can also deform, this deformation does not allow two parallel lines to intersect at one point because the two parallel lines would deform simultaneously and remain parallel after the deformation. According to the principles of black holes, two parallel lines may simultaneously terminate at a certain point in time, but this does not cause them to intersect at one point. The holographic theory of the universe also cannot prove that two parallel lines will intersect at one point. According to holographic theory, two parallel straight lines carry the same information and are equal. Once formed, they will continue to move forward in parallel along a fixed trajectory. However, in the unified field theory of the universe, two parallel lines will intersect at one point. So, what is the unified field theory of the universe? Scientists have been debating this, which is why the unified field theory has yet to be established. So how can I say that two parallel lines will intersect in the unified field theory of the universe? Scientists believe that there are only four fundamental forces in the universe: electromagnetic force, gravitational force, strong nuclear force, and weak nuclear force. But relying on these four forces alone cannot establish the unified field theory of the universe. According to the uncertainty principle of quantum mechanics, people realize that the motion state of fundamental particles, wave-particle duality, is related to the observer's method of observation. From this, some individuals who are not scientists but may belong to the category of scientists who are non-scientists realize that consciousness is related to the movement of matter. Thus, some have tried to incorporate the force of consciousness into the unified field theory, although this still does not constitute a complete unified field theory. I will briefly discuss the unified field theory of the universe in the chapter of Preaching Tao. For now, I will provide proof from the perspective of time and space to demonstrate that two parallel lines will intersect at one point. First, it is necessary to clarify that the traditional concept of time is incorrect. The idea that time flows uniformly is not in accordance with reality. The belief that time is unidirectional is also not entirely correct because time is a recorder of the motion state of matter. Time arises from the movement of matter, and its speed is closely related to the speed and mode of matter's movement, as well as the space in which the matter exists. Therefore, time does not flow uniformly but is constantly in motion and change. Furthermore, because matter can annihilate instantaneously, entering another spacetime, it leads to the creation of lateral time. Hence, time does not only have a vertical property from past to future but also a lateral property. Euclidean geometry is an abstraction of reality. To make two parallel lines intersect, we restore the abstraction to a concrete image and then observe whether they can intersect. Two parallel trains are an example of parallel lines. In a two-dimensional plane and three-dimensional space, they cannot intersect, they cannot collide with each other. If they collide, it no longer falls within the scope of the parallel line postulate. However, there is a scenario where this could happen: two parallel speeding trains are suddenly drawn into a lateral spacetime. Because the time they are drawn into differs by just 1 second, their trajectories change slightly, resulting in a collision. This is somewhat like two distant scenes intersecting due to the mirage phenomenon. Of course, this still doesn't fully explain Einstein's thinking. If Einstein were still alive, he would inevitably reach this conclusion: in the universe, there are no parallel straight lines that do not intersect or separate. Even if two parallel lines have the same mass and information, space has planes of intersection. At these spatial intersections, they can no longer run parallel. Moreover, as long as there is distance in space, the forces acting on the two parallel lines cannot be equal, and these forces will inevitably cause the trajectories of the two parallel straight lines to change, thus separating or intersecting. Two strangers sitting on parallel seats in a moving car constitute two parallel lines. A sudden car accident occurs, one person dies, the other survives. They do not intersect, the deceased is drawn into lateral spacetime. A few days or years later, the survivor suddenly has a dream in which he sees himself sitting in the seat where the deceased once sat, and they, the two parallel lines, intersect. Or, years later, the survivor also dies and is drawn into the same spacetime. They meet again and even become a married couple, resulting in an intersection. The conclusion is, there are no parallel lines that do not intersect or separate.